In this video, I'll show you how to solve problems where something is sitting on a slope. So sometimes it makes life easier if you rotate your axes. So that's what we're going to do here. First thing I'm going to do, though, is I'm going to make a free body diagram for that elephant. So elephant's there. We have gravity, points straight down. So there's gravity. There's also, if this ramp weren't here, that elephant would go right through it. And so we know that the ramp must be supporting it. That's a normal force, so it has to point out here, this direction. So there's the normal force. And in this case, we've got the elephant sitting on a water slide, so we're going to assume that the frictional force is 0. So there's no frictional force. If I have gravity this way, and then a normal up that way, the acceleration should be over here some direction. So net force is this direction, acceleration is always the same direction as the net force. So it'll accelerate down the water slide. That's exactly what we would expect. If there were friction in this problem, the friction would point directly back up the ramp. So holding the elephant that direction. When you're solving problems like this, if I've got normal force that way, friction that way, and gravity down here, I'm going to have to add up components. The gravity is in the y direction, so that's easy. This one's hard because I've got an angle. That one's hard because I've got an angle. But if you rotate your coordinate axes, it makes it easier. This is actually one of the very few times when it's easier to do this on video. So hang on. There we go. Now I'm standing sideways, but the elephant is standing straight for you. So now you can see that for the elephant, we have going in this direction, the direction of acceleration is now what looks like your x direction, right? I'm going to call that the parallel direction because it's parallel to the slope. I'm going to call this the perpendicular direction because it's perpendicular to the slope. Parallel, that's two lines next to each other. Perpendicular. So the symbol for perpendicular is this. The symbol for parallel is that. It's a terrible drawing, but two parallel lines. All right. So now, if we consider the parallel direction and perpendicular direction, then the F, that would be in the parallel. Normal would be in perpendicular, and it's gravity that we're going to have to divide up. So only the gravity has to be broken into two components.